Hey friends! Okay, so we have reached our last lesson together in this unit. Remember, this unit is talking about absolute value functions and reciprocal functions. We spent 3 lessons on absolute value functions. Yesterday, we introduced linear reciprocal functions, okay? Now today, we're gonna turn our attention to quadratic reciprocal functions. But do you remember yesterday, I talked about some kind of general rules as to how we create the reciprocal function. Now, we could go through every point we see on a graph and the x value would stay the same and the y value gets flipped. That's what taking a reciprocal means. But then we noticed some key characteristics yesterday when we were doing it. And what we were doing was we would know that I had a vertical asymptote where the original x-intercept was, because the value for y there is 0. And when I try to flip 0, I'll get something over 0. That's undefined. And that creates that vertical asymptote, okay? Then we add a horizontal asymptote at the x-axis. So on the full line, y equals 0 there. So that dealt with our asymptotes. Then we had invariant points, and invariant points are points that don't change when we go through a transformation. So for reciprocal graphs, they were located at y equals 1 and y equals -1. And you'll recall the reason is 1 flipped is still 1. And -1 flipped is still -1, okay? Okay, and then I talked about the fact that we have the reciprocal graph would always go in the opposite direction of the original graph. So if the original graph is increasing, the reciprocal graph would be decreasing. If the original graph was decreasing, the reciprocal graph would be increasing, okay? Something like that, okay? I was trying to watch my video and figure out my hand positions at the same time. And it was too complicated, but you get what I'm saying, okay? All right, so today we're gonna look at it very much the same as we did yesterday, where we're gonna try and get the original function written down first, and then we can use those rules to help us figure out the reciprocal, okay? The one thing, if you just look, I'm gonna hide my, yeah, we'll talk about it right quick. The one thing, I'm going to hide my face for a sec. The one thing that you have to also just pay attention to here, like look at this reciprocal graph up here. You would want to pay attention to this maximum has to get properly reciprocated. So that's a 4. So you would need to make sure that you plot at 1/4 down there, because 4 flipped would be 1/4, okay? So that's maybe one additive thing, or one addition that we didn't quite talk about yesterday because we didn't have those changes of direction in our graphs yesterday, okay? All right, I'm just gonna clear that ink if I can find my button, and we'll get started here. Okay, so sketch the graph of y equals x squared minus 2x minus 3 on the grid below. Determine the intercepts, the vertex, and the invariant points that would occur if we were to graph the reciprocal function, because we're going to do that in a minute anyway. Okay, so y-intercept, easy to tell. I plug 0 in for x and I'd get out -3, right? So I know I have a y-intercept at 0, -3. The x-intercept, I'm going to replace 0 y with 0, sorry. And I'm going to see if I can factor that. Do I know 2 numbers that multiply together to give me -3 and add together to give me -2? I do. They're -3 and +1. Using the zero product principle, this should all sound like sort of like old hat to you now, right? I got x equals 3 and x equals -1. So I know I have x-intercepts at -1, 0 and 3, 0. Okay. To get the vertex, I either would take the average of those guys and then get that new x-intercept at the vertex, plug it into the original function, and get out the y value at the vertex, okay? Sorry, I said that new x-intercept. I should have just said that new x value of the vertex, right? I'm not going to do it that way this time because I've done that way the last couple of lessons, so I thought I'd change it up a bit, and we will complete the square. So if I'm going to complete the square, these first two terms, I would have to factor out the coefficient from x squared, but there isn't one there. So now I just create that perfect square trinomial. I take -2, I divide it in half, and then I square it. Okay, so I know that I needed a 1, so I added the 1 and the -1. get the -1 out there. Just remember, you'd have to multiply it by whatever's out here. There just is nothing out there. So I can bring my -1 out to join my -3, and that'll be a -4. And then I'm left with this cute little perfect square trinomial that would factor into x minus 1 all squared. If that just stressed you out, I have a whole other video on completing the square. Go back to quadratics and just check that out, okay? I'm not trying to stress you out, I promise. It just seems to sometimes happen naturally. With me, I don't know, I'm a stressful guy. Okay, so that means I have a vertex at 1, -4, okay? 1, -4. So I found my y-intercept, I found my x-intercepts, I found my vertex. Now I want to take a look at invariant points. Okay, now remember, invariant points are at 1 and -1 for the y value. So what I do is I need to plug 1 in for y and solve for x, and -1 in for y and solve for x. So I'm going to start by plugging 1 in for y and solving for x. Okay, now to solve this, I'm going to need to bring my 1 over to the other side. So that's going to give me 0 equals x squared minus 2x minus 4. Can I factor that? No, I can't. So when I can't factor something, I head to the quadratic formula, everybody's favorite thing to use. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is -2, and c is -4. Okay, so here I am plugging all that into the quadratic formula. Underneath the square root sign, I've got 4 plus 16, so that'll be 20. 2 times 1 is 2. I can simplify the root 20. Root 20 is 4 times 5. The 4 can come out, so that'd be 2 root 5. And then everything can be divided by 2. So I have x equals 1 plus or minus root 5. Now, that gives me 2 invariant points with a y value of 1. Remember, I plugged 1 into the y value and I was solving for x, okay? So the 2 points I have right now are 1 plus root 5, comma 1, and 1 minus root 5, comma 1, okay? Okay, but now I can also get invariant points by plugging -1 in for y. So now I need to do that and solve for x, okay? So I just wrote the first 2 that I had down here so I wouldn't forget them. Okay, so I've got -1 equals x squared minus 2x minus 3. I'm going to add 1 to both sides so that I can get it equal to 0, and that's going to give me 0 equals x squared minus 2x minus 2. Can I factor that? No, I still can't. So I'm heading back to the quadratic formula. This will be wonderful practice on the quadratic formula. So a is 1, b is -2, and c is -2. Okay, so b, -b, that's where the positive 2 is coming from, right? Because it's -2, plus or minus the square root of b squared minus 4ac all over 2a. Okay, underneath the square root, I've got, this is -4 times -2, so that'll be 8. So 4 plus 8 is 12. 12 is 4 times 3, so the root of 4 can come out to be a 2. So I'm looking at 2 plus or minus 2 root 3 over 2. And then everything can be divided by 2. And so that'll be 1 plus root 3, plus or minus, sorry, root 3. Okay, so here's another 2 invariant points. There are 4 invariant points altogether. These guys are at 1 plus root 3, comma -1, and 1 minus root 3, comma -1. So this is everything I've got so far. I've got my y-intercept, I've got my x-intercepts, I got my vertex, I have my 4 invariant points. Now I'm going to plot all of this on a graph and draw the parabola that I've got. And then we'll talk about what to do for the reciprocal function, okay? But the first thing I want you to do is draw this parabola. So you want to pause me first to make sure you have a chance to do it nice and neat. Remember, it's not straight lines. It's not a V like absolute value. It's got to be a nice curved parabola, okay? Okay, so this is what you should be getting. Okay, so I've labeled the points in the same colors as they were in the previous slide. I did not put the invariant points coordinates there. I just put a big dot where those invariant points are, okay? So that's at y equals 1 and at y equals -1. And we can see why, visually, we can see why there'd be 4 invariant points here because there's 2 spots where y equals 1 And there's 2 spots where y equals -1. Okay. Now we're going to draw the transformed function 1 over f of x. So we're going to draw the reciprocal. Now, I want to walk you through the same sort of process that we did last lesson when we drew the reciprocal. First thing we did was we said, okay, we are going to have, sorry, I'm just trying to get ink on while I'm talking to you. I'm really bad at multitasking. We are going to have vertical asymptotes at our original x-intercepts, right? So that's at -1. So I'd have a vertical asymptote here. Remember, we're going to draw those in as a dotted line. They're not part of the function, but we use them. So that's why we put them in there. And then at 3 as well. So I'll have another vertical asymptote here. Okay. Then remember that I'll have a horizontal asymptote at y equals 0. And again, all of this is because I can't reciprocate 0, right? 0 reciprocated would be like a 1 over 0 type thing, and division of 0 is undefined. Okay, so I've got this split into 3 different sections. So the first thing I want you to do is to put in your asymptotes. The second thing I want you to do is to plot your invariant points, which we already have done. Those are the pink dots here. The third thing I want you to do is think about this whole concept of the reciprocal function goes in the opposite direction. So let's just deal with this outer section first. I can see that my original function is decreasing, so I need to be increasing. I need to be increasing, I need to hit that pink dot, and I need to ride along both of those asymptotes. So that's going to end up looking something like this. Okay. I'm going to scoot us over to here on this section for a sec. I'm going to, the original function is increasing, so I need to be decreasing. I need to hit that pink dot and I need to ride along the asymptote. So that'll look like this. Okay. I just had this thought while I was doing that, those of you at home may not be able to see what the question said. So I'm just going to hide myself for a second. It just said, now draw that transformed function. That's what we're doing. So 1 over f of x just means I'm doing the reciprocal of f of x. Okay. Okay. Now I need to deal with this middle section. Couple of things I need you to look at. First of all, the original function is going from decreasing to increasing, which means my reciprocal function needs to do the opposite. I need to be going increasing to decreasing, okay? There is one other important point though that I would want you to accurately plot, and it would be the reciprocal of this vertex, right? 1 comma -4 reciprocated would be 1 comma -1 over 4, okay? So just make sure, this is 1, 2, 3, 4, 5. So just make sure you've got an accurate plot of -1 over 4. Okay, so then this guy should look something like that. Okay, that's where about we should be. Okay, now here's the computer generated version of the same thing. And you can see I did pretty good. Okay, yay for me. Okay, now state the following information about the function. Okay, so I'm just going to make this a little bit smaller so I can add in my table. We want to look at the domain, the range, the equation of the vertical asymptotes, and the equation of the horizontal asymptotes. Okay, so the domain is going to be, reading from left to right, I could be anything I want except those vertical asymptotes. So I'm going to say x is a member of the reals, but x can't be -1 and 3. Then for the range, we can see that this top part is y is greater than 0. The bottom part is actually going to end up being y is less than -1 over 4, less than or equal to -1 over 4. I can't get any higher than that, okay? So you may have looked at this and said, why can't I just say y is a member of the reals, y can't be 0? Well, because of the shape of this graph, what I want you to notice is actually there's this whole little section inside here that y can't be. Okay, so it's easier to say it in two different steps. We say y is less than or equal to -1/4 and y is greater than 0. Okay, equation of the asymptotes. For the vertical asymptotes, we've got x equals -1 and x equals 3. And for the horizontal asymptote, we've got y equals 0. Okay, so here is all the information we just said. All right, just check yours against mine. Awesome. Okay, let's do it again. Okay, given the function g of x equals x minus 4 times x plus 2, sketch the transformed function y equals 1/g of x on the grid below by finding the intercepts, the vertex, and the invariant points. Again, just for those of you at home, I'll hide my big old head for a second so you can see the question. I'm trying to remember to do that more often. I apologize when I forget. Okay, so we're gonna go walk through the same sort of process. I'm gonna find the y-intercept, I'm gonna find the x-intercept, I'm gonna find the vertex, I'm gonna find those invariant points, and then I'll start plotting things, okay? So the y-intercept, I would plug 0 in for x, and I would end up with -4 times 2, which would be -8, okay? So I know I have a y-intercept at 0, -8. So this should have said equals, and then that should have said negative. Okay, sorry about that. Okay, then the x-intercepts. Well, I'm already in factored form. I just have to set that y value equal to 0, and I can say x equals 4 and -2. So that would be -2, 0 and 4, 0. Okay. And then the vertex. This time, because I had the two x-intercepts, I am just going to take the average of those two. So the x value for my vertex would be -2 plus 4 all over 2. That would equal 1. And then I just plug 1 into the original function and get out the y value for my vertex. So 1 minus 4 is -3. I'm just plugging in 1 every time I see x. Yeah. So that's going to give me -3 times 3, which is -9. So my vertex would be at 1, -9. 1, -9. Okay. All right. Just going to change that to -8 for you there. Oh, sorry. I got to, there. That's a little neater, little cleaner. I forgot about the ink on the previous slide. Now we're going to go for those invariant points. Now, it's probably easier when I'm trying to deal with the invariant points to multiply this fella out. So that's going to be x squared. I'm going to have 2x and -4x. So when I add those together, that'd be -2x and then -8. Okay, so I'm going to set that y value equal to 1 and to -1. So here I go with it equaling 1. Okay, I'm going to bring my 1 over, so it'll be 0 equals x squared minus 2x minus 9. I can't factor that, so I head to the quadratic formula. Some of you who want to throw things at your screen right now, just a reminder that that will damage your screen. It won't affect me. So don't throw things at your screen. Okay, A is 1, B is -2, and C is -9. So I end up with 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times -9, all over 2 times 1. -4 times -9 is 36, so that ends up being the square root of 40. That'll be 4 times 10, and the root of 4 can come out to be 2. And so I'm looking at 2. If I divide everything by 2, sorry, I'll be looking at 1 plus or minus root 10. Okay, so for y equals 1, there are 2 different points. So I'll have 1 plus root 10, comma 1, and 1 minus root 10, comma 1. Okay, so now what I want to do is plug in -1 for y and go through the same sort of process of solving. Okay, so I just stuck those first 2 down at the bottom, so I had them there. -1 equals x squared minus 2x minus 8. I want to add 1 to both sides. That's going to give me 0 equals x squared minus 2x minus 7. Is it factorable? No, it's not, but that's okay because we have the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, underneath the square root, I've got negative 4 times negative 7, which is positive 28. 4 plus 28 is 32 over 2. 32, I can take out actually a 16 there. 16 times 2 is 32. So the root of 16 is 4. So I'd have 2 plus or minus 4 root 2 all over 2. Divide by 2, and I get 1 plus or minus 2 root 2. Okay? So these two invariant points would be at 1 plus 2 root 2, comma, negative 1, and 1 minus 2 root 2, comma, negative 1. Okay? All right, so now I am ready to plot all of these things. I'm going to do it the same as I did the first guy. I'm going to kind of just mark those invariant points. Actually, I didn't put any of the coordinates on for this coming guy. I just put the dots there, okay? Okay, so you pause me, you graph, and then we'll compare notes. Welcome back. Let's compare notes. We've got something like this, okay? So you can see my vertex is at 1, negative 9. My y-intercept's at 0, negative 8. I mirror imaged it here. I've got my 4 invariant points. I've got my x-intercepts at negative 2 and at 4. Okay, everything's good. Now, I want to walk through creating the reciprocal graph. So I'm going to start with those asymptotes. I've got the asymptote, a vertical asymptote at x equals negative 2. Remember to put those as dotted lines. I've got another vertical asymptote at x equals 4. Of course, you would be using a ruler, not a mouse with a shaky hand. Horizontal asymptote at y equals 0. And then you can see the 3 sections that I've got here. Okay, in this section, I am decreasing. So my reciprocal function will be increasing. I have to hit that invariant point and I have to ride along the asymptotes. Okay, in this section over here, I'm going to jump over there and I might be in the way for you there. So I'm just going to hide my head for a sec. The original function is increasing, so I need to be decreasing. I need to hit the invariant point, that big pink dot. Okay. Then in the middle, I've got, again, this notion of the original function was decreasing and then switches to increasing. So I need to be increasing, switching to decreasing. Okay. The y value of negative 9 here needs to get reciprocated to negative 1 over 9. So that'll be very, very close to the x-axis. And so I'd be looking at something that looks like this. Okay. That was bad on my part. I shouldn't be going away from the asymptote. You should be riding right close to the asymptote, okay? I blame the fact that I'm trying to hold a mouse and record a video and move my hand at the same time. That's my excuse. Okay, but I do have, like the cooking show, I'm ready to go. I do have the computer-generated version to show you the good version. Okay, let me just bring that up for you right here. So that's what it should look like, okay? A reminder though, you still need arrowheads on yours, okay? You'll notice the computer-generated version doesn't, and that's allowed. But for hand drawings, you always need the arrowheads, okay? All right, awesome. Now, I gave you a question like this, sort of like this, in our last lesson. But this time round, I just gave you slightly different information. I want to see how we handle it. Given the graph of y equals 1 over f of x, so this is the reciprocal graph, sketch and determine the equation of the original linear function, okay? Well, my eyes dart to that asymptote right away at negative 1. I know that's going to be an x-intercept, okay? So an x-intercept at negative 1, 0, I know. Now, I was given this point on the reciprocal graph. Well, that actually tells me what the point would have been on the original graph, right? Because I just reciprocate y. So the original graph would have had to have been -2, -4. So suddenly I find myself with two known points, okay? We know that on the linear function, we would have the points -1, 0 and -2, -4. So I'm gonna build an equation of a line that passes through those 2 points. The first thing I need is my slope, y2 minus y1 over x2 minus x1. -4 minus 0 is -4. -2 minus -1 would be -1. And so that ends up giving me -4 over -1, which is just +4. Okay, so I have a slope of 4. That tells me that I've got y equals 4x plus whatever b is. Okay, just gonna hide myself for a second to make sure you can see that. Okay, and so now what I could do is just plug one of those points in for x and y, either the -1, 0 or the -2, -4. I chose the -1, 0, plug that in for x and y so I can solve for b. 4 times -1 is -4. Bring that over to the other side, so b has to equal 4, which means my equation is y equals 4x plus 4. Okay. All right. Now, then I've given you the graph of the line because it said sketch as well. Okay, so I know I have a y-intercept at 4, and then I had a slope down 4 over 1, down 4 over 1. Okay. Yay for us. All right, good job, guys. All right, match the following functions with the correct graph of the reciprocal. Write the equation of the reciprocal functions. Now, on your page, you're looking at 6 graphs altogether, where the left side is the original and the right side is the possible reciprocal functions, okay? You take a minute and do your little matchy-matchy first, okay? What I'm about to show you is which one matches with which original, okay? So for this guy, and I'm just going to kind of walk you through how I would draw each of them, okay? For this guy, I know that I have a horizontal asymptote right here, okay? I know I have an invariant point here and here, and I know I would need to be increasing and then decreasing. So the graph should look something like this. Okay, so do you see that on your page? Yes, you sure do. It's this one right here. Okay. Now, in order to get the equation of this guy, it's easiest just to get the equation of this guy. I have a vertex at 3, 0, so that'll be x minus 3 brackets. That's in brackets, all squared, right? Now, I have an a value here. I can tell that my a value is 1 because I'm going over 1 and up 1. I'm going over 2 and up 4. So there is no stretch factor here. Okay, so this is the equation y equals x minus 3 all squared, which means this guy is the equation y equals 1 over x minus 3 all squared. Okay. All right, next guy looks like this. Again, I'm just going to go through that same process. I know that I'd have a horizontal asymptote here at the x-intercepts and here. Okay, I know I'd have invariant points at 1 and -1. Okay, so now that gives me enough to get my rough sketch of that on that side and that on this side. And then this guy would have to go like that, right? So I'm looking for a picture that looks something like that. And I can totally see that on my page. It's this guy right here, okay? So if I want the equation of this guy, I know I have a vertex of 1, -4. So that would be x minus 1 all squared minus 4. For an a value, again, I'm going up 1 over 1 and up 2 over 4. So the a value is 1. I'm good with that. So that's going to be x minus 1 all squared minus 4. So the reciprocal function would be 1 over that, 1 over x minus 1 all squared minus 4. Okay. Then the last guy looks like him, cute little linear one. I know I have a x-intercept at 2, so that'll cause my vertical asymptote. I know I have my invariant at 1 and at -1. This is decreasing, so I need to be increasing. I didn't actually draw the horizontal asymptote in for any of these, but you do know that it exists, which is why I'm bending that way. Okay, so I'd be looking at something like this, and I do see that picture, and it's the picture I haven't chosen yet because I can use process of elimination at the moment. Okay, all right. Now, this is the graph. I've got a y-intercept at 1, 2, 3, 4, and I have a slope of down to right 1, so -2. So -2x plus 4. So this guy would be 1 over -2x plus 4. Okay, y equals 1 over -2x plus 4. Isn't that a fun game? All right, that's where our game stops, and that's where our lesson stops. Your homework, I've listed there. The other thing I wanted to make a note of is in your workbook, you do have a 2-page summary after your homework. Just to wrap up this unit, it summarizes absolute value and reciprocal functions. So it would be a good idea to read through that as well. And as always, if you have any questions, please come find me. You know where I am. Come get me. All right. Yeah, that's it for this unit. If you're following my order of events, the next time we'll see each other is to begin sequences and series, okay, which will be unit 6. Okay, so I will see you there very, very shortly. Take care, guys.